let's see. Okay, I guess this is working. Let's hope so. Okay, I believe it's working. Um, yeah, it's working. Let me just hear the voice. Yep, the voice is already on. So yeah, welcome to the stream of me actually solving my homework problem. So yeah, we will call this thing LiveWork. And yes, today we are going to be talking a little bit on derivatives. And yes, let me just actually go and find what problems I need to solve. Okay, so yes, I am going to be doing this all here on my laptop, and yes, we've got a couple of problems that we need to actually to try on. So let's just actually go and just start. Okay. So let me just actually first write the question first. This is from my Indonesian book called Matematika untuk SMA atau MA kelas XI kelompok wajib. So yes, this is basically general maths. And so yeah, let's start with the first with the first question, which is the second number on this page. So number 2. Let's go and start this. Turunan, which is basically the derivative. Let me just actually, instead of doing this, let me just actually use text instead. Yep, it lags. Okay, yep, there we go. The derivative of fx equals to 7 over 3. Multiply that by x, multiply that by the root of 7, which is something that I cannot write. So let me actually just do this instead. So yes, I am here just trying to also to experiment on how should I do this thing live. 7 over 3. There we go. Let me just select this thing a little bit. There we go. 7 over 3x multiply by the square root base 7 of x to the power 5. Yep. Unfortunately, I cannot write properly. So yeah. So the derivative of function x is 7 over 3 times x times 7 times the root of 7 of x to the power 5 is, let me just write it, and let me just put it there, go, is, and here are the choices. A, you know what, let's don't actually use choices instead. Let's just straight away and solve this problem. So, how should we get started with this problem? So the first thing I would say is to actually, just to start by writing this. So yes, to find the derivative of function x means that yes, you are just finding df oh wait, no, sorry, I forgot that this question is function prime of x, which is equal to this guy. So yeah, this guy here is basically df over dx. Dx, there we go. And so the first step that I'm going to be doing is to just actually to transform these x's into powers. So this would actually help So this would actually help your solving. So yeah, let's start by actually transforming this. So yes, we are trying to find the f over dx. Let's move this guy down. So first things first, let's just go ahead and write this 7 over 3. Still not changed because this is still f. It's 7 over 3. Multiply that by x to the power of 1, because x to the power of nothing here is basically x to the power of 1. Multiply that by x to the power of 5 over 7. Yep, I know this guy is not that clear. Let me just actually, the stroke is already 1 pixel, so yeah. So it's 5 over 7. Okay, it works. So let's just actually go ahead and just simplify this a little bit more. This would actually result into 7 over 3 multiply by x to the power of 12 over 7, which is basically 1 plus 5 over 7. And so from here, we will just need to try to find the derivative. The way for you to actually to find this is actually using the law of, well yes, it's not a law, but yeah, the way for you to actually to find the derivative of this function here is just by actually, let me just go here. Yep, we are there. So df over dx must equal to, this is how I will actually be writing this, 7 over 3, which is basically this number here, and then we multiply this by the derivative of x to the power of 12 over 7. Let me just go and do that. Just take the derivative, and what you will actually get is, let me just actually go here first. Okay. Let me just go ahead and just open my channel as well, just in case. So yeah, let's just actually take this derivative first here. The way, so yes, the way for you to actually take the derivative is just by putting this guy in the front and then subtracting this guy by 1. And that's basically it. So yeah, let's go and do that. It will be 7 over 3 times 12 over 7. Multiply that by x to the power of 12 over 7 minus 1, that would be 5 over 7. 5 over 7 there. Which would basically, we can just cross this out here. That's 1, and then we can cross that out to get ourselves 4. So we would actually get 4 to the 7th root of x to the power 5. Boom, there we go. And that would be, in my problem here, it would be d. So yeah, that's how you actually try to find the derivative of a function. It's basically very simple. Our third problem. So yes, let me just actually get myself a pencil. Nope, that pencil doesn't work. Let me just actually go ahead and find it first. Well, I think I just lost it. Oh well, I guess it's not under there. So yeah. Oh, there it is. Found it. So yes, the answer, it would be D there. Okay, so second problem. Let's go with the second problem here. Let's just go and just type. For number 3, find the derivative of function x equals to, let me just write this down now, 3x squared plus 5x and 6. And let me just actually move this guy down. Yep, there we go. Is function derivative of x. Yep, there we go. Is function derivative of x. Oh no, sorry. It's only that, so yeah. So yeah, the way for you to actually to solve this problem, same thing. Just take the derivative. But yes, this time this time the x's aren't at multiply, instead they are at addition. So yeah, to solve something in additions, the way for you to do it is to just to calculate each one by one. And that's how you actually gonna be solving this. So let me just go and just find the derivative. The f over the x. So yes, at the top there I used a little bit of the longer way, but yes, let's go and just do this a bit more faster. So just multiply this 3 by this 2, you'll get 6. Multiply that by 2 minus 1, which is what? X to the power of 1. And then for this guy here, plus 5, which is basically 1 times 5, that's 5. Multiply that by x to the power of 0. And then this last guy here is a constant. So yeah, we could just say that it's plus 0 because it's a constant. So yeah, with all this here, we should be getting, let's see here, where's my, yep, there it is. It equals to 6x plus 5. Because yeah, x to the power of 0 here is just basically, it is just basically 1. So yeah, and thank you very much for Lunatic who is actually watching this. I don't think that he has already learned this, but yeah, it's good for you to actually to learn something pretty early on. Okay, so 6x plus 5, that would be A. So let me just write that thing there, A. 6x plus 5. Okay, next, let's go and just write this thing again. Type it. If function x let me just move it there. If function x equals to the function here, let's go and just write that down, 2 over 3 x cubed, there we go, minus a quarter x squared. Yep, there we go. Space, and then function derivative of x equals to something. So the way for you to actually to find this is just by taking the derivative, because there's like that prime notation. Yes, I always say the accent as prime. So yeah, just so yeah, All you need to do is just to try to find the f prime of x. The way you do this, let's just do this method quickly as well. So let's go and just multiply this. So let's just write this first, the f over the x there, oops, yep, equals to 3 times 3, that's, no sorry, 2 over 3 times 3, that's 2, multiply that by x to the 3 minus 1, that's x squared, subtract that by a quarter times 2, that would be minus half, multiply that by x to the power of 1. So therefore, we got here is it is 2x squared minus half, minus x over 2. And this would be, okay, yeah. In my book, we don't have, the problem is that there is no solution corresponding to this solution. It is instead like some sort of it's some sort of the factor, right? So let's actually just try to factorize this guy. So we can actually go ahead and just throw the x out here. So in order for me to actually to create the same function as the top here, is that I need to think. So let's start by 2x squared divided by x. That would be 2x. And then minus x over 2 divided by x. That would be minus half. And so that would be one of the factors, but unfortunately I don't have any of such factors. So let's actually just go ahead and just try to get this half away, because yeah, inside this bracket I'm hoping that there is no integers. No, sorry, no fractions. So yeah, let's just actually go ahead and just do this. So let's do x over 2 instead. From here, that means that in order to get this, I need to divide this 2x here by half. Yeah, dividing 2x by half, that will be 4x. And then minus half divided that by half, that will be minus 1. And in fact, this guy is D. So yeah. So yeah, we have found our fourth question. So yeah, let's go to the next slide here. Oops. Oh wait. I have actually run out of the page. So yeah, let me just try to figure out how to add a new paper, a new page. So yeah, let me just try to find this. I'm finding this, edit colors, blah blah blah, by settings, object. Settings, object, no. Type select, effect, view, window, image extensions, no, no. Oh yeah, let me just ask an illustrator. Edit pages. So yeah. What about yeah, page. Yep. There's like unfortunately there is no such thing as pages. So yeah, I just need to try to figure something out. Let me just actually go the preview preferences. No. Layers, no. I forgot what is it called. Is it this here? Artboard navigation number 2. No. Next. Selection. Show. Artboard name. No. Wow. So yeah, that's one page, unfortunately. Let me just actually open up a new file first, because I don't understand how to use this guy. Oh, edit artboards. Yep, that's A4 here. Rearrange all, transform. Name of the artboard. What's this? New artboard. Oh look, I did it. Good, good. Okay, so I have figured it out. How to add new artboards. Not pages, artboards. So let me just go ahead and just get towards my type tool. Zoom in. So, what question are we at? Number 5. Okay. Ooh, this one. This one is interesting. Okay. If g of x, let me just put this guy a bit downwards there. If g of x equals to let me just write this guy in. Let's try to make sure that this guy is not that thick. Could I 0 pixel? That's still very big. Unfortunately, I don't understand how to make this guy a bit more thinner. Well, I guess this is what I'm going to be using. So yeah, if g of x is 5x squared, whoops, 5x squared, x squared plus, let me just put you a bit more to the sides, there we go, plus 4 px minus 3 minus 3, there we go. And then we still have some more text. And g prime of 2 is 4. Okay. We have gotten some variations. The value of g prime of 1 must be equal to something. Okay, so in here we've got a different type of variation. So this time we have gotten ourselves into like some more algebraic notations. We have gotten x and we have gotten p. So how do we actually differentiate? No, sorry, derive. No, how do we take the derivative of this function here? So the way we are going to be doing this is first by actually finding what g prime of x is. G prime of x. There we go. So let's actually go ahead and just try to find the derivative of x. No, the derivative of g. So let's start by differentiating this first. This first thing here, 2 times 5, that's 10. Multiply that by x to the power of 2 minus 1, which is 1. Great. And then after that, we want to add it. Plus this guy, which has a power of 1. So yeah, x to the power of 1. So, and by the way, the p here doesn't really affect the function, because the function here is in g. So that means that, yes, the x will be, so yes, the function will be affected by x, but p is a constant. It never changes. And and you're asked to actually to find what P is. That's the first question, and also the second question is just find the derivative of 1. So yeah, when we do this, that's 4p, because that's 4p times this 4p times 1, the to the power of x to the power of 0, which is 1 in this case, and then we add it by 0, which is the constant at the backside here. And so we have gotten ourselves this function 10x plus 4p. Good. So what do we do now? Well, basically, we are going to be substituting this 2 inside this function. So the g derivative of 2, which normally people write it as g prime of x, take the derivative, and then x equals 2. It's something like that. That I see most people do it outside of Indonesia, but yeah, for me, I actually do it like this. So yeah, let's actually just go ahead and just do this. Put the 2 in, that's 10 times 2 plus 4p. Make sure that it's 4p because you're just substituting the x. So yeah, it's 10 times 2 plus 4p equals to 4. Okay. So from here, I can find a p pretty easily. So let's actually just do 20 plus p, just 20 plus 4p is 4. Well, that's simple. And then we can just put this guy onto the other sides, or basically other people call it like, yeah, subtract 20 from each side. It's still the same, so yeah, you'll get 4p equals to negative 16. Let me just write that down first. Minus 16. There we go. And so we have discovered p to be negative 4. Good. But this is not a question. We are not asked to find what p is. Instead, we are asked to find what g prime of 1 is. So what do? We basically just try to find g to the prime of 1. Very simple, right? So let's just substitute the numbers in. 10 times 1 plus 4p. Same thing, 4p. Because yeah, this guy here also states that it's at only 4p. So yeah, the p doesn't change. No, sorry, the 4p doesn't change. So yeah, this would equal to, let's go ahead and just multiply this first. That would be 10. And then you add it, by 4 times p. But we know what p is. P here is actually negative 4. You can see here. This negative 4 here can be placed at the front side here. And then from here, you would actually get, so p would equal to, no, sorry. So g prime of 1 would be 10 minus 16, which is equal to negative 6, which is our answer. So you have found out what this derivative is. So yes, you have found the way for you to actually to solve this problem. What you normally do is just to try to find the constant. In this case is p. But then yeah, sometimes that the problems actually you cannot try to find the p or the q, for example, but it might be a function that that you can later use to be put inside your um, asked question. So yeah, that's how you find this question. Next up, it's number 6. Okay, let me just drag you there. We still have some more space, so yeah. Number 6. Um, it is known that function x equals to, let's write this down, x to the square root of x plus 1 over square root of x okay. That was the question that is asked. Oh wait, no, sorry, there's still no. So function f prime of x would equal to something. So how to find this? This is the same thing as before. We transform all of the things into powers, because yeah, we are still talking about some arithmetics. Like yeah, we are not going to be caring a lot about trigonometric functions and how you actually differentiate it. Although I have already known about this. So let's go ahead and just define this. So this x to the power of 1, multiply that by x to the power of half, which is square root of x. So yeah, this is function x here. So the function x there, okay, there we go, equals to this guy, plus x to the power of negative half. Why negative half, you might ask? So the first thing is that, yeah, the x to the power of half is actually at the bottom. So the way for you to actually flip it is just by adding a negative into the front. That's how you actually flip the power. So yeah, with this here, let's just actually simplify this guy here into x to the power of 3 over 2 plus x to the negative half. So yeah, that's good. And so now all I need to do is to try to find what the derivative is. So to find the derivative, it's the same thing. You go this 3 over 2, multiply that by the front here, which is 1 in this case. So yeah, it's going to be 3 over 2. Multiply that by x to the power of 3 over 2 minus 1. That's half. Okay, that's pretty good. And then you add it by 1 times negative half. That will be negative half at the front. Multiply that by x to the power of negative half minus 1, which is negative 3 over 2. So with this would equal to, let's actually try to simplify this now, but no. Well, yeah, actually, like, yeah, the base should be the same now. But nah, I won't do it now. So yeah, this would be 3 to the square of x over 2. Subtract the thing by 1 over 2. And yes, this guy here is actually 1 plus half. So you can actually write it as x times square root of x. Because yeah, this guy is 1, this guy here has the power of half. So yeah, 1 plus half, then will be 3 over 2, and then you flip it. And so with this, let's actually go ahead and just simplify this a bit more. So yeah, let's just make sure that the denominator is the same. So yeah, we can just multiply. So yeah, we just need to make sure that the the denominator will be the same. That will be 2x to the square root of x. And then after that, we are going to be multiplying this 3 to the square root of x here by x times the square root of x, because yeah, this guy here is missing the x times the square root of x. So with that, we will actually get 3x to the square root of x squared, which we could actually just cross them out to be only x times x minus 1. So that will actually be 3x squared minus 1 over 2x squared of x. And so, in conclusion, the answer would be C here in my book. And that's how you actually solve this crazy power stuffs. So yeah, some crazy things. So now, let me just actually circle this guy in. There we go. So let's start a new artboard, which I forgot how you actually do that. Edit artboard, new artboard. Yeah, there we go. I'm starting to get the hang of this. So yeah, let's start. Number 7. The derivative of g of x equals to 3x, let me just write that down. 3x to the power of negative 2 minus x over 2 plus square root of x. Okay. Is g to the g prime of x, which equals to something. So, how do we solve this? Well, this thing is also the same. But yeah, let's first actually just transform them all. So g of x here would equal to 3x to the power of negative 2 minus x over 2 plus x to the power of half. So with this would actually equal to, let's go ahead and multiply this 3 by negative 2. We would get negative 6 here to the power of x to the power of negative 2 minus 1. That's negative 3. And then let's subtract that by x. Let's go ahead and multiply by 1 times negative half at the bottom there. That would be negative half to the power of x to the power of 0 times x to the power of 0. And then lastly, this last guy here, yep, that would be 1 times half, that would be half times x to the power of negative half. There we go. This is dg over dx. This would equal to, let's just go ahead and write this guy in, minus 6 over x cubed. Because yeah, that's because this guy here is a negative, so yeah, we put it down there. And then x to the power of 0, that's 1, so we can just write as minus half plus half of square root of x. And so with this, we would actually get, we can just rearrange that a little bit. That's minus 6x cubed plus 1 over 2 square root of x, yeah, minus half. So the answer would be E. In this case, it would be e. So yeah, taking derivatives is actually pretty simple. Oh, I see how. Wait. Wait, can I actually just reduce this guy? 3 oval? Wait. Oh! I can write something much more thinner. So yeah, it's better. So yeah, let's actually start by doing number 8. Number 8. And I didn't turn on the AC. Great. Okay, so the derivative of a function x equals to 2x plus half x. Oh, wait, no. Let's just write that in. This would be half. Oh, yep. That's very thin. Wow. Okay. So this would be 2x plus 1 over 2x at x equals to 1 is, okay, so for this question, all I want you to do is don't put, I say don't put this guy inside here. That would get you 5 over 2, which is not the correct answer. In fact, what you need to do is to actually to take the derivative first, because here it's asked for the derivative. So let's actually go ahead and just do that. So let me just rewrite this first. 2x plus half of x minus 1. There we go. Evaluated at x equals to 1. That is what you normally actually write. So yeah, you do this here. Or yes, probably sometimes it's d of this guy over dx. But yeah, for me, I would just actually write it like this instead. Let me just write it like this. Function x there. Function x is this guy. So yeah, now all you need to do is to actually take the derivative first. Function prime of 1. No, function prime of x. And yeah, by the way, this guy is actually asking you for f prime of x. No, f prime of 1. That's basically the question. So yeah. So the after derivative of x would equal to 2 times 1, that would be 2, multiply that by x to the power of 1 minus 1, that's 0. Um, half times negative 1, that's negative half, minus half there. Multiply that by x to the power of minus 1 minus 1, by negative 2. So this is what we get. That's 2 minus half x squared. So let's just actually evaluate this guy. So yes, I think I just did a little bit of switch ups sometimes. Yeah. Starting off, we got df over dx, and then getting longer, I'm just mixing those two. But yeah, those guys means the same. So yeah. So yeah, it should be much more fine. So with this here, this would actually equal to f prime of 1. That would be 2 minus. But the one inside of the 1 right over here, that's the x there. We would actually get minus half there. Very simple, right? And then when you evaluate this, you'll get 3 over 2, or 1 half, which equals to 1 half, which is something that I don't really use to write, but yeah, that's something, and the answer would be B. So that's how you solve that problem. So let me just actually circle in all of the things that I have already solved because I don't want to do this again, even though that I will actually going to be rechecking all my things. So next we got okay, I can read that. Okay, so let me just go with downwards there. I think we still have some more space, so yeah. Let me just go ahead and just write this guy in. If function of x equals to 4 to the, no, let me just write it down because we're not. 4 to the square root of x minus 4 over the square root of x minus 4 over 3x to the square root of x plus 4 the value of f times 1 is what? So yeah, same thing as before. We'll first actually just try to find the derivative. And yeah, let me just actually go ahead and put this guy in. There we go. So let's go ahead and just start. Let's actually start by taking the derivative. Even though that I'm already very used to doing this entire thing on my mind, but yeah, the best way for you to actually to do this is to just to write it, because yeah, you know what to multiply something with something while also subtracting by 1, and that's how I do it. I just multiply this guy by the top side here, and from there you would actually get your numbers. So yeah, very simple. For x to the power of negative half, right over there, minus 4 over 3 x negative of 1 plus half, that's 3 over 2, plus 4, and this is still function x. There we go. Okay, so let's start by finding what f derivative x is. Let's go ahead and just first plug numbers in. No, let's start by deriving the powers, which is simple. So yeah, 4 to the power of half, that will be 2. Yeah, so yeah, 4 times half, that's 2. To the x to the power of half minus 1, that's negative half. Second part, minus 4 times minus half, that will be plus 2. X to the power of negative 3 over 2, that's minus half, minus 3 over 2. No, sorry, minus 1. And then next one, minus 4 over 3, multiply that by minus 3 over 2. That will be another 2. And somehow I messed up writing the 4 there. Yep, 2x to the power of negative 5 over 2. Add this by 0, which is this guy here, the constant. It's just a lone number. So we can actually just rewrite this as 2 over square root of x there, plus 2 over x to the square root of x, plus 2 over x squared x. So yeah, from here we want to try to find the f derivative of 1. So yeah, from here you can actually just factorize this again to something else, but yeah, because of this question, I'm not going to actually do that. Instead, let's just put it in. So yeah, we will get that 2 divided by the square root of 1. The square root of 1 is in this case 1. And then 2 divided by 1, that will be 2. Add this by 2 over 1 plus 1 times 1, that will be 2. Add this again by 2 divided that by 1 squared times the square root of 1, that will be total of 2. And so that would be 6, which in this case is A. And that's how you solve it. So let me circle out that the answer is A. Next up, the new artboard. Edit artboard, new one. There we go. So let me just cut back up. There we go. Cat a little bit there. Okay. Let me just actually put that. Okay, continue. Okay, so this is the next question. If f of x equals to, okay, let me just write this down. Let me just, oh wait, I did actually write the number. Okay, 10. There we go. Have I actually been writing the numbers? Let's see. 7, 8. Yep, this guy I didn't. No. There we go. Okay, so function x here. Okay, let's start by writing this one down. P of x cubed minus 8x squared plus 3. Wait, let me just actually check a little bit. Yeah, that. Okay, but then yeah, there is still more. And f prime of 2. Okay, so when you take the derivative and then plug in 2, you'll get 16. Goes to 16. So so the value of f1 minus 4f derivative of 1 plus 2p equals to something. So let's actually solve this. Okay. So there's actually multiple ways for you to actually solve this. But let's actually use the most easiest way. That is the most straight-minded one. But yeah, you can. But yes, you can also just use your other ways, such as plugging this guy straight into here, which I'm going to be also showing you how I will do it. But I don't think that it's going to be that effective. So yeah, my personal method is to try to find the f derivative of x first, because yeah, we both need to try to find this. So f derivative of x would be 3p. Yeah, so yeah, it's p times 3, that would be 3p. X to the power of 3 minus 1, that's power of 2. Minus 8 times 2, that will be minus 16. Multiply that by x to the power of 1, which is 2 minus 1. And then plus 0, which is the constant. So this is basically 3p x squared minus 16x. And this is how my method differs from the normal way, which is my personal method that I don't really recommend for you to use, but yeah, sometimes you might need to use it. So this would be the common way, and this would be mine. And let's see which one is much more effective. So first, let's try to find the function derivative of 2. Why? Because we know that function derivative of 2 is 16. That means that we can actually try to find what p is. So this would be, plug in the 2 inside in, so that will be 3 times p times 2 squared minus 16 times 2 would equal to 16. Okay, so let's actually solve this guy. 12p, which is 2 squared, that's 4, times 3, that would be 12p, subtracted by 32 would equal to 16. And so 12p equals to 48, p would equal to 4. I don't know if this would be needed for my other method, but according to my prediction, let's actually see about my prediction. It would be p minus 4p, so no, minus 12p, so yeah. Wait, no, sorry. P would go there, and then minus 12p, that's minus 11p, and then minus, yeah. Probably my way wouldn't be that effective anyway, but yeah. Let's see how far we should do this. And so now, let's actually go ahead and just try to find the thing that we need to solve this guy. We need function 1, function prime of 1, and p, which is the one that we have already found. So yeah, let's start by finding function 1. Function 1, right? There is, yes, there is no x in there. That means that we are going to be using this guy here. So substitute the numbers in. We got p times 1 cubed minus 8 times 1 squared plus 3. Well then, that's simple. That's p minus 5. But yeah, we can just go ahead and just put in 4 there. 4 minus 5, the back end, that would equal to negative 1. And so, that will be our first number, and then we also need to try to find the after derivative of 1, which that means that we need to put it inside this guy here, which is the derivative. So we got 3p times 1 squared subtracted by 16 times 1. This would equal to 3 times 4, that's 12p. Yeah, 12. Subtracted by 16. This would be negative 4. And so when we combine them all together, function 1 minus 4 prime of 1 plus 2p would basically be, just plug the entire numbers in, subtracted by 1, add that by 16, that's negative 4 times negative 4. So let me just actually write it instead. Negative 4 times negative 4 plus 2 times 4. So when you do this, that will be minus 1 plus 16 plus 8 would equal to 23, which is D. But what about my method? Well, my method would basically simply start by function 1 first. Just try to find what function 1 is. In this case, we have found this right over here. and that would be p minus 5 at the end. And then I just need to try to find the function prime of 1. That would be 3p minus 16. And so with this, I'm going to be straight away calculating what this guy is. And I think it might be a bit hard, but yeah, let's see. I think, like from my prediction, it will be a bit more harder. So yeah, p is 5, subtract that by 12, because we are going to be multiplying this by -4, plus 64, plus 2p. This would be negative 9p, 66 plus 61. And then we just need to try to find what the p is, which we have gotten from here, because I don't want to double do it. So with this, it would be minus 36 plus 61. And obviously, this guy is 25, which somehow breaks my law as well. I think I've made a mistake somewhere. Let's actually see. Minus 10 minus 9p, 66, yeah, that's plus 61. But then we know p is 4. So yeah, we plug that number in negative 36. That's 25. Which is not in my problem set. Wow. Wow, 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 wow. Wow. Wow, wait. Something is not adding up. It's minus 8 plus 3 and that's negative 5. And yeah, this is why I do this other method here, just to see if something might break, which in this case it did. So yeah, it's function 1 subtracted by 4. Yeah, so that's 16, 24, yeah, 24 minus 1 is 23. But somehow this guy, from what I got, it turns out to be 25. So something is not adding up. Obviously something is not adding up, which is the fact that I don't know where. So yeah, I know that the p would be 4 because I've already calculated it correctly. Let me actually just check. Yeah, 48 minus 32, yeah. This seems fishy. So yeah, multiply that by 4, that's 4 to 64, yeah. By plus 2p, and then subtract that by 10p, plus p, which we get a very different answer. Wow. Wow. This might be worth the investigating. 4 times 9, that's 36. And then just add them up. Huh. Oh, wait. Oh, I see where. I accidentally add up this guy here, which is not the part of the thing. So yeah, this would be. Well, let me just erase this. There we go. So in fact, this would be minus 59 plus 59. Sorry, plus 59. That would mean it's 23. So yeah. So yeah, make sure to double check your answer. That's the first thing. Second thing, make sure that you write your numbers correctly. And yeah, one of my problems is that I just write the p a bit weird. So yeah, my brain didn't actually detect that. So yeah, that would be 59. So yeah, same thing. We would get ourselves D, 23. Okay, so now let's jump to question 19. Question 19. the derivative of y equals to, let's write this guy down, x minus 1. Do we still have space down here? Yep, we still have lots of space, so yeah. X minus 1 times x squared plus x plus 1, is it? Oh wow, yeah. Plus x plus 1. Okay. So yes, there is actually two different ways for you to actually to solve this. The first way is to just to multiply this guy in. Just, yeah. Multiplying those two in is one of the most easiest methods. Because what you actually get here. So yeah. Let me just separate that, and yeah. This guy here is actually, so yeah. The first one is just by multiplying. Multiply. Oh wait. Is y prime equal to. So yeah. We'll wait for it to solve this. Pretty crazy, I know. So basically, we have this formula here. Basically, a minus b of a squared plus ab plus 1 is, no, plus b is actually a cubed minus b cubed. And yes, this fact is actually something that you might not actually remember, but yes, somehow I still remember this. But yeah, if you want to multiply this, it is just basically this guy multiplied by this guy multiplied by this guy, and etc. But yes, you can. But yes, you can. But yes, you can actually just multiply it, just simply like that. So yeah, with this here, that's, so yeah, the a here is x, the b here is 1. So when you check, it's x minus 1 times x squared, that's a squared, plus x times 1, that's true, plus 1, which is in fact true. So that means that this guy here, y equals to x cubed minus 1 cubed, which is 1. And so we just need to derive this. That is basically 3x squared. And this is basically b. But there's also a different way for you to actually to solve this, and that's by using the formula. The formula. So, how do you do the formula? For the formula, we will be assuming something as something and something as something. So here, this guy here, let's say that's u. And for this guy here, let's say this is me. No, just kidding. It's v. So for the formula, let me just complete the sentence. Formula. For the formula, it's basically the derivative of uv is basically the derivative of u times v divided by the derivative of v times u. So yeah, with this, you can actually try to find what your thing is. So yeah, let's first actually go ahead and just try to find what u prime is. u prime in here would be x minus 1, divide that, that's 1 times 1, that's 1, so it's 1 times x to the power of 1 minus 1, that's 0, and that would actually equal to 1. Simple. So now, let's start finding v prime. V prime here is basically 2 times 1, that's 2, multiply that by x to the power of 1, there we go. Add this by 1 times 1, that's 1, multiply that by x to the power of 0. Oops, sorry about that. This would equal to 2x plus 1. And so with this, we can just plug it in into our formula. And so, when you put it inside our formula, you'll actually get u prime, that's 1, multiply that by v, in this case it's x squared plus x plus 1, add this by the derivative of v prime, that's 2x plus 1, yeah, the derivative of v, multiply that by u, which in this case would be x minus 1. So with this, we can actually just multiply this guy here. You will get x squared plus x plus 1 plus, let's go ahead and just multiply this guy, 2x times 2x, that's 2x squared, 2x minus 1, no, 2x times negative 1, that will be negative 2x, plus 1 times x, that's x, so in total that will be negative x, and then lastly, 1 times negative 1, that's minus 1. And then with this, we can actually just cross this out, negative 1 with plus 1, x with negative x, you'll get 3x squared. But yeah, this would also be b, but yeah, it takes longer for you to actually solve this. So I would recommend for you to actually do it by the multiplying method, because it's much more easier. And so this one, ooh, this one here might take a while. But yes, there is also 2 different methods for you to actually derive this. But yeah, you need to make sure which one that you are actually going to be doing, because yeah, same thing, 2 different methods. But for this guy, I need to actually do this by multiplying it. Even though that it will be a very long multiplication, the answer choice that I was given is all of them separated. It is not like multiplying it. So yeah, I don't really like it, but yeah, let's just actually do it in 2 different ways. So number 20, the first derivative, that's basically the first accent, the first derivative of the function, of the function, there we go, is the function f of x equals to, of the function, let me just enter that function, x of, let me just write this guy down, equal to 4x squared plus 3x plus 5 multiply that by x cubed minus x plus 1 let's go back to text. is function prime of x equal to something. So, same thing, two different methods. So let's actually use the multiply first, and then we'll use the formula. So let's go ahead and just multiply this, which would take a lot of time, but yeah. Let's actually just do this a bit of the quicker way. So yeah, let's go ahead and just try to find everything that has the power of 5. So yeah, the way for you to actually to determine which one to use on a multiple choice is just by looking at its choices. Because when you actually just use another method, it might be hard for you to go back just to multiply them all together. That would be much more harder. So I would just first multiply this first. So yeah, function x of, let's go ahead and just try to find the highest power, which is x, which is 5. The way for you to get it, it's 2 plus 3. So yeah, 2 plus 3. So let's go ahead and just multiply this guy. So that would be 4 times 1, that's 4, x to the power 5. Good. Next one. Let me just go ahead and just erase this first. Whee. There we go. So now the next highest power would be x to the power 4. And there are actually two different ways for you to get it. One is just by multiplying x to the power of 3 times x, that would get you x to the power 4, or x squared times x squared. But in this case, we don't have that many x squared. So yeah, we only care about this guy here. 3x times x cubed. That would create the 3x to the power 4. So let's write that down. 3 times x to the power 4. So yeah, I forgot to write this guy. This is multiply. So yeah, mult. So yeah, that's the power 4. So next, let's try to find something that would make an x to the power of 3 now. The way for you to get x to the power of 3 in here is to actually multiply this guy here, 5 and x cubed, and there is actually another one, which is 4x squared. Multiply that by x. That would also create the x cubed. But is there anything else? For this time, there is no other thing. So yeah, we just need to calculate this 5 times x cubed, subtract that by 4x cubed. That would be 1x cubed. So yeah, let me just write that down. Here, plus x cubed. And then after that, let me just okay. There we go. Come on, go back out. There we go. And then after that, we want to multiply the x squared, which is the 4x squared times 1, and the 3x with the x. That would create all of the x squared that we need. So yeah, that's 4x squared minus 3x squared. That would be x squared. Simple, right? Math is not that hard. But the thing that is hard is how you actually use that data and finding the most effective way, because most people actually fail because of time management. And yeah, first one is time management, second one is you get stuck on the math problem, and the third one is you miscount. So yeah, make sure to pay attention to all three. And so now let's actually just try to find everything that would multiply into x. So 3x times 1, this guy and this guy, and also 5 times negative x. So that would create the x to the power of 1. And so if we calculate that, that's negative 5x plus 3, that's minus 2x. Good. And now finally, we just need to find the one that's power 0, which is 5 times 1. So that will be plus 5. So good. We have discovered this entire thing. And so now we just need to derive it. So let's go ahead and just derive the function, derive it. There we go. This would actually be 20, 4 times 5 to the x to the power of 5 minus 1, that's 4, plus 3 times 4, that's 12. Multiply that by x to the power of 4 minus 1, that's 3, plus 1 times 3, that's 3. Multiply that by x to the power of 3 minus 1, that's 2, plus 1 times 2, that's 2. Multiply that by x to the power of 2 minus 1, that's 1. Subtracted by 2 times 1, that's negative 2, times x to the power of 0, which is nothing. And yeah, plus 0. But yeah, we don't need to write that. And this is actually already on my solution. That's 20. That's 20x to the power of 4 plus 12x cubed, and then it's plus 3x squared plus 2x minus 2. And that's our solution. So in this case, this would be C. But you might be asking, well, what about if I use the formula? Well, I don't recommend it, but you can try. So let's actually go ahead and use form. So to do form, let's assume this guy to be U and this guy to be V. So yeah, same thing. Let's go ahead and just first try to find what U prime is. U prime would be 4 times 2, that's 8, to the x to the power of 2 minus 1, that's 1. And then add this by 3 times 1, that's 3, times x to the power of 1 minus 1, that's x to the power of 0, which is 1. And then plus 5, which would be the plus 0, so yeah, we don't need to write that. And then for v prime, that would be 3x squared, 3 times 1, that's 3, multiply that by x to the power of 3 minus 1, that's 2. And then we subtract, and then we multiply that by negative 1 times 1, that's negative 1, times x to the power of 0, which is 1 as well, and then add by 0, so yeah, with that, let's go ahead and just put it into our formula, which would be pretty long, so yeah, 8x plus 3, there we go, multiply this by x cubed minus x plus 1 add this up by 4x squared plus 3x plus 5 multiply that by 3x squared minus 1, and so go ahead and just try to find it yourself. This would be a long one, but it would be the same. So yeah, you see that, yeah, there are actually two different ways for you to actually integrate it. No, sorry, to derive it. One of them is just by multiplying it straight away, and the other way is to use the formula. But the best way for you to use it is also knowing the time. So that's why I first multiplied first, because it would save me a lot of time rather than using the formula, which is very tiring. So that's why I don't really use the formula a lot. But I still do. Why? Because this formula here could be used for functions such as sine x, multiply that by cos x, and then you just try to find it, and you'll try to find the derivative. That would help you. But yes, but yes, for this case, you just need to know the situation, because yeah, not every time you need to use the formula, because sometimes using the formula would make things much more harder. Because yeah, after after you multiply it, you also need to add it as well. So yeah, I would rather just multiply it straight away and then just derive it, and then just derive them all. That's how I will, and that's how I do it. And that's why that you need practice, just to try to find the most effective way to solve the derivatives of function. So yeah, that's the goal. So now let's actually go and just add in a new layer. Edit artboard, new one. There we go. Let's just go to the very top, the sides. There we go. Let's go with number 29. 29 is the next question. Oh yeah, and that's the final question. What? No, 26. Wait, wait. Okay. So yeah, 25 first. Okay. So number 25. This time we start with dy over dx. Okay. Well, yeah. The grammar doesn't work, so yeah. I need. I just need to move this a little bit. There we go. So yeah, 25. The dy dx, yeah, that's better, I would say. Well, let me just delete that first. Move this guy. So 25. The dy over d. So the dy dx from y equals to this time the question is different, because instead of we actually derive powers, instead we are starting to derive functions. So yeah, 3 4x minus 1. Yes. So yeah, let me just write that. Is. So how do you actually solve this problem? You might think it's hard, man. I cannot actually do this. But actually, for you to actually try to find the dy over dx, which is basically the derivative of this function, it is basically pretty simple. But yes, sometimes this guy is actually written very confusingly, and that's, for example, if you have a f of u, that would equal to u prime, and then after that, wait, I I also still struggle on how to actually to write this guy. Okay, so first up, it's the derivative of u, multiply that by u to the derivative of x, which is totally crazy. Yes, I mean, like, what? Well, yeah, actually like that. Yeah, there we go. But yes, the way for you to actually write this, it's pretty much like that. but yeah, sometimes it's like df dx equals to, oh wait, no, yeah, so yeah, so it's df dx, multiply that, no, sorry, yeah, df dx equals to df du times du dx. Well, basically, the thing is that you could later just cross out those du's, but yeah, this is very confusing. So instead, how I normally think is something like this. So yeah, first, let's just actually transform this cube root into power, because yeah, powers in derivative is much more better. So yeah, 4x minus 1 1/3. There we go, to the power of 1/3. So the way that you do this is to find the derivative. You'll first try to find the derivative of the outermost shell, which in this case is this function here. The power. The power is the outermost shell, which is basically the very outer layer is actually the power in this case. So just derive this guy like a normal function. So when we do that, we can actually just do that 1 times 1/3, that's 1/3. Multiply that by 4x minus 1. You see, I just copied the same function which is inside that function. And then after that you do that 1/3 minus 1, same thing, that will be negative 2/3. So now, from here, this is still not complete, because you still need to do one thing. You want to derive the inside. Yes, the inside here, which in this case it's pretty simply times 4 times x to the power of 1, which is basically 4. And so with that, you should have already found the answer, but yeah, it's a bit complicated for me to actually look at from here. So this is basically 4/3 to this cube root of 4x minus 1 cubed. No, squared. Sorry, yeah, squared. And yeah, from here, you should have already found the answer, which in this case, it's actually 4/3. That's B. And so yeah, this is this is how you actually solve this type of question, which is like basically a function inside of another function. That's basically the core of it. But yeah, sometimes that, yeah, you need to also learn this. So yeah, let's actually do number 26, because number 26 is actually pretty similar. So let's actually go ahead and just do that. 26. Number 26 here, function x. No, sorry. The derivative of function x. No, sorry, of fx. Wait. Oh yeah, yeah. The derivative of fx equals to this crazy root of 4 5x squared minus 3 is, so this this question is basically pretty similar to the upper one. So yeah, let's just transform this root into powers, because yeah, that has helped us a lot. So yeah, function x here is actually equal to 5x squared, the inside, minus 3 to 1 to the power of 4. So how do we solve this? So remember, we start by the outermost shell, which is 1 over 4. So let's go ahead and just write that down. 1 over 4. So yeah, that's basically 1 times 1 over 4. And then after that, we want to... Oh, I just can't stop looking at number 27, because this is interesting, because there's 3 different ways for you to solve it. But then there's actually one of the most effective way to solve it. But yeah, I think I'll just leave it to you to actually figure it out. No, just kidding. So yeah, we want to go ahead and just write this 5x squared minus 3, which is the same function inside of the shell. And then yeah, the way for you to derive this power law is just by subtracting this guy by 1. So in this case here, let me actually just remove that function prime of x. Sorry, yep, there we go. So that would be minus 3 over 4. Multiply that by 5x squared minus 3. You derive it, that's basically 10x. Yeah, 5 times 2, that's 10 multiplied by x to the power of 2 minus 1. And so with this, we can conclude that the solution would be 5 over 2. How do you get that? Cross this guy, that's 2. Cross that guy, that's 5. So 5 over 2 to the cube, this guy here. Oh yeah, don't forget the x at the top of this guy, 4. 5x squared minus 3. Okay? And so there should be a solution. Oh wait, yeah, there is. But yeah, it's still at 10x minus 4 over 4 to the root of 4 of 5x squared minus 3 cubed. So yeah, that's d basically. And so let's do number 27. And let's actually do this in the most effective way. Although I'm going to be actually showing you how do you do it in the most complicated way. If function x equals to, let's go ahead and just write this down, x plus 1 to the square root of x squared minus 2x plus 1. Then function prime x equals to something. So if you don't see the pattern, the most ideal way for you to do is that you actually realize that if you actually want to take the derivative of this guy, this is basically a multiplication law. Just by assuming this is u and this is v, but then you realize that if you want to derive v, you basically need to use the thing at the top here. So then you need like lots of these formulas, but then you realize one thing: x squared minus 2x plus 1 is actually x minus 1 squared. And then when you realize this, you can actually just cross this guy out, and instead you have x plus 1 times x minus 1. But then, yeah, if you still don't see the pattern, you can actually just still use the multiplication law, and you don't need to use like the chain law, which is the top side, I should say. That's called the chain law. But then, yeah, you say, wait a minute, x plus 1 times x minus 1. That's basically x squared minus 1. This is one of the most common um, identity, probably. No, it's like a formula. It is the most common formula. So yeah, that's basically function x. I still haven't taken any derivative, but yeah, if you have realized this, then you'll just say, wait, does that mean that the derivative here is actually simply just 2, that's 1 times 2, multiplied by x to the power of 2 minus 1, which basically x. So it's basically 2x, which in this case it's true. It's b, and this is why every time you want to do derivatives, try to make sure that you can actually simplify it into the most comfortable one that you can do. You don't need to overthink it. Just saying like, well, I got 2 things that needs to be multiplied. That means that I need to use the multiplication law, but then one of the parts actually is required for you to do the chain rule. So you just did the chain rule, and then after that you did the multiplication law, which makes you insane. So that's why the first thing that you want to do to solving these types of question is first, just by simplifying it into the most simplest function. So yeah, something like this guy here makes it effective. And yeah, this is basically where math comes in. The math basically states that you want to get something into the most simplest form first before you apply those crazy rules. Because like yeah, math is all about logic, and yes, for logically something to be easy, you want it to make it shorter, much more easier for you to read, and you can do crazy things with them much more easily. So yeah, that is something that you need to keep in mind. So next one, okay, g of x. So yeah, let's go ahead and do that. Number 29, the final question. It is known that g of x equals to, let's write this down, the big square root of x plus 2 to the square root of x. Okay, got the value g prime 4 equals to, and you might say, man, the square root of x inside the square root of x, what do you mean? Well, basically it means that it's a square root of x inside of the square root of x. That's basically it. But then yeah, this is something that you can actually do. Watch. G of x must equal to, obviously, for you to do derivatives, is just by turning those roots into powers first, because that is something that makes you much more happier. It makes you solve those questions easily. So yeah, square root x there, that's square root 1 over 2. But then inside this big cage, you also get this 1 over 2. And so when you actually just try to find the derivative of x there, watch what you can actually do. realize this, that this guy here is basically the power. It is basically the power law. No, sorry, the chain law. So so yeah, you just go ahead and just do the chain law. That's 1 times half. That's half. Multiply that by the same function as before, x plus 2 times x to the power of half to the power of negative half. And then after that, you want to multiply this again. Yeah, you want to multiply it again by the derivative of this guy, which is basically, let's put a cage, x. So yeah, 1 times 1, that's 1. Multiply that by x to the power of 1 minus 1, that's 1. Add this by 2 times half. 2 times half, that's 1. Times x to the power of half minus 1, that's negative half. So what do you get here? Basically, what you get is 1 plus the square root of x. There. Divide the entire thing by 2 of x plus 2 to the square root of x. But don't forget, this entire thing is square rooted by x, by this other guy. But then what's so then what's the value of g prime of 4? And this is basically something simple for you to actually solve. Watch carefully. G prime of 4. That's right. You don't actually need to simplify everything that you have. Like, yeah, this guy here turns to square root x plus 1, and then you put the square root x at the bottom. And then inside you just multiply them all by x. It's sometimes unnecessary for you to do that in calculus. In fact, the most comfortable one should be the one that you always use. Like, yeah, for example, this guy here, it's already very comfortable. Watch. This 4 here can basically delete this guy. But yeah, you can also just put this g prime over 4 right over there. But yes, I am not comfortable at calculating something like that. So instead, I actually do it like this. So if you actually go ahead and just do this, it's basically 1 plus 1 over the square root of 4. That's basically, at the top side, that would be a 3 over 2. Yeah, that's 1 plus half. Divide the entire thing by 2 times the square root of 4 plus 2 times the square root of 4. So the downside there would be 2 times the square root of 2 times 2, that's 4. 4 plus 4, that's 8. The square root of 8. And so we can actually just write this as 3 over 2 times 2, that's 4, times 2 to the square root of 2, which is basically the square root of 8. And so with this, you can basically calculate that this guy is actually 3 over 8 to the square root of 2, but we want to rationalize this, so yeah, we multiply the top and the bottom by square root of 2, and then what we got at the bottom is actually 16. 3 to the square root of 2 over 16. And that's basically C. And you have actually found the solution towards this problem. And so that's basically all the things that I'm going to be actually solving for today. So yeah, this, so yeah, this, I don't know how many numbers are there. That's 9 plus, that's 11, and then that's 14. So yeah, 15 questions that I have solved for today. Wow. And yeah, obviously, this is a pretty crazy thing. because like yeah, basically, so yeah, basically, deriving something is actually very, it's it's actually very easy. Taking the like yeah, taking the taking the derivative is something very easy to do as long as you know the tricks. Because sometimes if you use the wrong tricks, like yeah, for example that yeah, so for example like the problem that I have, whoops, let me just try to find it. Um, let's see which one is it. This one here at the bottom, number 20. Number 20 basically states that yeah, it is very hard. Like yeah, it's it's literally very hard for you to do it if you use the formula. But sometimes you need to use the formula to actually to solve this problem. But yeah, at this case, there is the most effective way is just by starting by multiplying it first. It's the most easiest way. But then yeah, sometimes that yeah, you might get a function that that like yeah, you need to actually to find the you need to try to find the derivative of the multiplication, and then inside the multiplication there is like the derivative, but then sometimes inside of that chain law you also need to use the multiply and then chain law. But then yeah, obviously there's like some other question that use chain law and then chain law again, then chain law again, like yeah, multiple chain laws, which sometimes drives people crazy, seeing like thousands of chain laws. But yeah, but yeah, those laws will be used with each other. But yeah, in this question, it was not asked the about the quotient law, which is a bit of a variation from the from the multiplication law. But yeah, I won't do that for you because it would be crazy. So yeah, that is so yeah, that is all I will be sharing with you today. And yeah, thank you very much for you who watched this until the very end. I hope that this will be helpful towards you and also the rest of you. And yes, if you have any questions, you can just leave it on the chat or at the comments. So yeah, thank you very much for watching the stream, and I'll I'll see you guys later.